Hi, this is Reed from California, and in this lesson we are going to be learning the basics of the gyro sensor. So, first things first, make sure that you have the LEGO Mindstorm's Education EV3. So, I've got the Teacher Edition, that's just something that you can click during installation, but if you have the Education version, it means that you have access to many more sensors and other nice things. So it's completely free. Just look it up, and can probably find it pretty easily online. Alright, once you've done that, take one of these gyro sensor blocks out, and we can see that the gyro sensor looks kind of like this. I'm not sure if it actually has that little symbol on it on the actual sensor, but it doesn't really have a output like the color sensor or the ultrasonic sensor does. What it does is it measures the angle that it's at compared to where it started and the rate of movement or acceleration. You can find these gyro sensors online as like for Arduinos and other microcontrollers as like circuit boards, and this one is simply in a little plastic box, and it works really well and it's great. So you can also compare the angle and the rate like other sensors. When you compare it, it's just, is the current reading greater than, less than, or equal to like this set number? Or the last option here is to reset it, and what resetting does is it takes the current reading of the gyro sensor in all aspects and then makes that the 0. It's kind of like hitting the tare button or the 0 button on a scale. It just sets everything to 0. So for example, if you started your program with your robot in a certain position and then your robot turned right, and then you want one to make the new position the baseline position and rate for all of the gyro sensor readings, then you'd reset the gyro sensor. So there's many different applications that you can use the gyro sensor for, like, say, driving straight or doing an accurate turn. And all of these are very useful, especially when you don't have a line on the ground or something else that you can follow in the area that you're trying to drive through. So we're going to make a sample program that just drives straight, and this seems like it would be simple, but it's actually a little more complicated than it seems. However, it's really useful because if you've ever tried to make a robot drive like 3 meters forward, it is inevitably going to turn a little bit or not go perfectly straight because the motors aren't perfect. Nothing is perfect. So this helps a lot. So let's start. First, we're going to reset it because it's just always good. It should be reset in the beginning, but redundancy never hurts. So we're going to have 2 lines. They're both going to have loops. So we're going to take out a loop, put it there, and then copy it and put another one there. So the first one, let's actually connect these. The top one here is going to control the actual driving. So you can just use Move Tank. I don't know, I like Move Tank, it works. I'm pretty sure Move Steering also works. So we're just going to turn it on. And now we want it to, so this should just go straight, right? But we want the robot to, when it senses that it's turning, like let's say it's turning to the right a little bit on accident, then we want it to be able to sense that and then change the power so that if it's turning to the right, then you want the right motor to power up a little bit so it goes back straight. So we could just like put this at a higher number, but that's not going to work because you can't do it live. So we're going to put a variable in that another part of the code can change. So let's just call it right motor power. And then we're just going to read it here because we want to use it to control the power of the right motor. So we'll put another one for the left motor too. And why we're putting these variables here is because if we put variables here, then we can write the variables in another section of the code and it will change it live. So it will change the power to the motors. Now you may think, oh, well, why? Because we've already declared that it's going to be moving at a certain position, but we've put it in a loop. So that means that, like, every very short amount of time when this loop repeats, it's going to be sending the motors another command that's slightly different. Alright, so we've done those now. Now, in this bottom one, this one's going to be this loop is driving, and this loop is sensing. So we want to take this gyro sensor, and then, so we want the distance from 0, right? That it's going to be off, because if it measures 0, then the robot's straight and everything's fine. So we're going to use the math block, and we're going to take this and put it there, and we're going to take 0 and we're going to subtract, because this way, let's say it's 0 degrees, right? Then that's great because 0 minus 0 is 0, so we should change these by 0. However, if this is, let's say, 5 degrees, then 0 minus 5 is negative 5, and that's bad. So it will change it by negative 5. You could do this way, but there's a lot of ways to do a lot of things, and this probably isn't the easiest way, so we're going to do it a different way with a if statement. That way would look simpler and it would be simpler on the code, but conceptually a different way with a switch statement is much easier to grasp. So we're going to read gyro sensor. We're going to compare the angle, and if it's not equal to 0, then we're going to be like, oh no. But if it is equal to 0, then it'll run the code here, which we're not going to put anything there because we don't need to do anything if it's 0. Wait, no, never mind, because we put a not equal to here. It'll run this one if it's 0. So the stuff in this area is what we need to do if we need to change any aspect of motor power. So we're going to be up here, and so we need to change, right? We need to change the power of the motors, but in order to know how much we should change it, we should read the gyro sensor. So we're measuring the angle that it's at, and then we're going to set our variables up here to a different amount. And in reality, you actually only need one variable. Oh, I never set this to left. You only need one variable because while it would be effective to, if you're going one way, speed up the opposite motor, or if the other way, speed up the opposite motor, so that if you're going right, then you'd speed up the right motor, and if you're going left, you speed up the left motor. But you can do it with only one motor, and that's a lot simpler. So we're going to delete that, because this way, if we're turning left a bit, that means the right motor's going too fast, or the left motor's going too slow. So we can just slow down the right motor, and it will work the same. So let's say we've got, I don't know, 5 degrees off. So then we're going to have 5 as an output here. Then, if we write 5 here, that's not going to work because then I'll set the motor power to 5. We need to take, so this is probably going to be 50 to start, so we should declare that in the beginning. We can make this a my block later if we want, but I'm not going to cover that in this video. So we'll just set it to 50 just to start, because if you don't give it anything to start, it'll kind of be confused and it won't like you. So it's going to be 50, right? So we got to do math. Let's try to get this math block. And so we're going to do 50 minus this. Now what this is going to do is, if this is a positive value, then it's going to subtract it from 50. So let's say you're veering 5 degrees to the right, then it's going to be positive 5 degrees is the reading of this. So it'll be 50 minus 5, and then that will set this to 5 less. So that isn't what we want. So because it will accelerate it to the right. So we should add instead. Now, if you find that this is going the wrong way, like if it starts to turn and then it just keeps turning that way, then you should swap this from plus to minus, because it basically inverts everything. And that could happen if you had B on the right and C on the left or something like that. Now that's all the math we need to do, so we're just going to do this. Oops. That. And then this is our basic program to drive straight. Hopefully now you've got the basics of the gyro sensor. And in the next lessons, we'll go more in depth and see things like the physical sensor and where we should put it, and also more code and more applications that you could do with this gyro sensor.